In this video, we are going to learn how to solve the linear differential equation, and particularly we are dealing with the homogeneous linear differential equation with constant coefficient. Let's start with this example. So very first step we will write its operator form. So its operator form is d square y plus 2 dy plus y is equal to 0. Since it is a second order derivative, that's why we are writing a d square. It's a first order derivative, it is a simple d, and there is a no derivative, so we will keep it as it is. Now take y common, so we have the coefficient of y as d square plus 2d plus 1 y is equal to 0. Now auxiliary equation in this case is replace d by m and y by 1, put it is equal to 0. Now this is basically m plus 1 whole square. So we have from here m plus 1 into m plus 1 is equal to 0. So this implies either m plus 1 is equal to 0 or the second factor m plus 1 is equal to 0. So this implies the value of m is equal to minus 1, and even from here we have m is equal to minus 1. So we have two roots and both the roots are same, that is equal to minus 1 and minus 1. So whenever we have a equal root, suppose m1 and m1, so two roots are there and both are equal. So in that case, the solution is written as this is equal to first constant e raised to power first root into x plus second constant e raised to power second root into x, although second root is same. So we need a linear independent solution. For that we will multiply by x. So this is further written as c1 plus c2 into x e raised to power m1x. So we will use this formula in order to write the final answer. So according to this, the final answer is the complementary solution is equal to c1 plus c2 into x e raised to power. So what is the value of m1 in this case? That is the minus 1 into x. So this is the final answer in this case. So next example is this. So in this case again we will write the operator form. So operator form is d square y plus 2 pi into dy plus pi square into y is equal to 0. Now take the coefficient of y, that is d square plus 2 pi into d plus pi square. Now write the auxiliary equation. For auxiliary equation, we will replace d by m, that is m square plus 2 pi into m plus pi square, and y is replaced by 1. Now this is the quadratic equation. Although we can directly find that this is the m plus pi whole square. In case you are not getting that, you can use the formula of quadratic equation of this form. So from here the value of a is 1 and the value of b is 2 pi and the value of c is pi square. So finally we are getting solution as m is equal to, so b is 2 pi, so minus 2 pi plus minus under root b square, that is a 2 pi whole square, minus 4 into a, that is 1, into c, that is a pi square, divided by 2 into a, that is 1. So simplify this, minus 2 pi plus minus under root, this is 4 pi whole square minus 4 pi whole square divided by 2. So this is equal to minus 2 pi plus minus, this is getting a 0, so root of 0 is a 0 by 2. So again we have a two roots, that is minus 2 pi plus 0 by 2, and second is minus 2 pi minus 0 by 2. This is further is equal to minus pi and minus pi. We have same roots, m is equal to minus pi and minus pi. So both the roots are same. So in that case the solution is ycx is equal to c1 plus c2 into x e raised to power minus pi x. Let's answer the next question. Write the operator form. So operator form is 9d square y minus 12dy plus 4y is equal to 0. So take the coefficient of y, that is 9d square minus 12d plus 4y is equal to 0. Auxiliary equation in this case is 9m square minus 12m plus 4 is equal to 0. So now find the roots. You can directly apply the formula in this case. So that is minus b. So the b value is minus 12 plus minus under root b square, that is a minus 12 square, that is 144, minus 4 times of a, that is 9, into c, that is 4, divided by 2 into a, that is 9. So we have this is equal to 12 plus minus 144 minus 144 divided by 2 into 9 is the 18. So this is equal to 12 plus minus 0 upon 18. So again we have two roots, that is 12 plus 0 by 18 and second is a 12 minus 0 by 18. So that is equal to 12 by 18, that is the 2 by 3 and 2 by 3. So equal roots are there. So from here we have a two roots and both are equal, that is 2 by 3 and 2 by 3. So in this case the general solution is written as complementary function is equal to first constant plus second constant into x e raised to power root, that is 2 by 3 into x, and that is the final answer in this case. Next question is this. So write the operator form again. So we have 4d square y plus 4dy plus y is equal to 0. So take coefficient of y. So we have 4d square plus 4d plus 1 into y is equal to 0. Now write the auxiliary equation. So from here we have the auxiliary equation as 4m square plus 4m plus 1 is equal to 0. So 1 we can try to separate these terms. So we can write 4m square plus 2m plus 2m plus 1 is equal to 0. From here take 2m common. So we have further 2m plus 1. And from here take 1 common. So this is 2m plus 1 is equal to 0. So we have the common term 2m plus 1. So remaining is the 2m plus 1 is equal to 0. So what are the values of m from here? So from here we have m is equal to minus 1 by 2 and minus 1 by 2. In this case the solution is ycx is equal to c1 plus c2 into x into e raised to power minus 1 by 2 into x. Next example. So let's again write its operator form. Its operator form is 25 d square y minus 20 dy plus 4y is equal to 0. Now take the coefficient of y, that is a 25 d square minus 20 d plus 4 into y is equal to 0. So auxiliary equation in this case we have 25m square minus 20m plus 4 is equal to 0. There's another way to answer this question. One is a factor form and second is a formula. Even there is a third way. If you observe that this is the 25m square. So we can write this is as a 5m whole square. And this is a 4, so we can write it as a 2 square. Now we need to observe whether we are getting this type of a form, that is a square plus 2ab plus b square, or it is of this form a minus b whole square, that is equal to a square minus 2ab plus b square. So in the first case all the signs are positive, but here one sign is negative. Let's observe whether it is get converted into this form or not. So we have a in this case is 5m and b as a 2. So it is written as 2 times of a into v. So let's split this one. So this is a 2 times of So 20m can be split as 2 times of 10m. But in this case, A is 5m. Let's split further this one. This is 2 into 5 into 2 into m. So if I club 5m together, and this is the value of B and this is the value of A, in that case we will get this term. So we can write it as twice of 5m into 2. So we are getting a same term as written over here. So this implies this is equal to 5m minus 2 whole square is equal to 0. So we have two factors and both the factors are same, that is 5m minus 2 and 5m minus 2. So in this case the value of m are 2 by 5 and same from the second factor 2 by 5. So final solution ycx in this case is first constant plus second constant into x e raised to power 2 by 5 into x. This is the one way to answer this question. Second, you can split the middle terms, or third cases you can apply the formula. Let's answer the next question. So in this case, again write the operator form. This is the second order derivative, that is a d square y plus there is a no derivative. This is as it is 25y is equal to 0. The coefficient of y is d square plus 25 into y is equal to 0. So auxiliary equation in this case is written in this form. So now from here, m square is equal to minus 25. Now take square root on both sides. So we have m is equal to plus minus square root of minus 25. Now what is the square root of 25? That is 5. Now what about minus 1 square root? So that is written in complex form iota. So we have now complex root. Whenever we have a complex root of this form a plus minus iota b. So in that case, the general solution is written as in three formats, that is the exponential, cos and sine. So in case of exponential, we will take the real part. So real part in this case is a multiply by first constant cos of imaginary part. Imaginary part is basically b into x plus c2 sine of imaginary part, that is b into x. This is how we are writing the complementary function in case of the imaginary root of auxiliary equation. Compare these coefficients. So from here, what is the value of a? So in this case, we can write this is equal to 0 plus minus 5 iota. So from here, the value of a is 0 and the value of b is, that is the coefficient of iota. Substitute these values over here. So final solution in this case is e raised to power 0x c1 cos of 5x plus c2 sine of 5x. So e raised to power 0 is 1. So we have cos of 5x with the first constant plus c2 sine of 5x. So this is the final answer in this case. Let's answer this question. So write the operator form. This is d square y plus 4dy plus 5y is equal to 0. Now collect the coefficients of y, that is d square plus 4d plus 5 into y is equal to 0. Auxiliary equation is m square plus 4m plus 5 is equal to 0. Now we need to find the roots in this case. Now can you find the two numbers whose product is 5 but the sum is 4? So product is 5 only in a two case, 1 and 5, minus 1 and minus 5. If you take the sum of first one, it is a 6 and its sum is minus 6. We will never get 4 in this case. We can say we are not getting an integer whose product is 5 and the sum is 4. So let's try to apply the formula in this case. According to the formula, we have m is equal to minus b. So that is minus 4 plus minus under root b square, that is a 4 square 16 minus 4 into a is 1 into c, that is the 5 divided by 2 into a, that is 1. So this is equal to minus 4 plus minus under root 16 minus 20 by 2. This is further is equal to minus 4 plus minus, that is a minus 4 by 2. Further we can write minus 4 plus minus. Root of 4 is 2, but the root of minus 1 is iota, divided by 2. Simplify this. So this is minus 2 plus minus iota. Now roots are complex. So write the final answer in this case. So complementary function is equal to, so answer in a 3 part, exponential, cos and sine. In exponential we are taking the real part. So it is a e raised to power ax, that is the minus 2x into C1 cos of imaginary part. What is the coefficient of iota? That is the 1 into 1 into x, that is the cos x, plus C2 sine of x. And this is the final answer in this case.